A new definition. A normal line is perpendicular to a tangent line, meaning the product of their slopes is -1 or the slopes are negative reciprocals of each other. A tangent line is what I marked in red. A normal line is perpendicular to it. So it tells you a lot about the movement of a particle along a path. Very useful, has a lot of applications. So in this example, find an equation of a normal line to the curve at the given point. If you substitute 2n, you get 2/4, which is 1/2. The equation is y minus y1 equal m into x minus x1. So we have y minus y1 is 1/2. The slope, I'm going to find x minus x1, just like we did in algebra. We're going to be doing that for a while. So to find the slope of the tangent, that's the derivative, quotient rule, derivative of the top times the denominator, minus the top times derivative of the denominator all over the bottom of the denominator squared. Evaluated at x equal 2. I could clean it up and plug 2 in, or just throw 2, that's a 4, that's a 2, and a 2 in there. 2 plus 2 is 4 squared. So I'm getting the derivative, which is the slope of the tangent, to be 2/16, which is 1/8. So my slope for the normal line is going to be the negative reciprocal. There it is, done. Very straightforward. If you can find the derivative, everything's going to fall into place. Let f of 2 equal 3, g of 2 equal -4, the derivative equal 5, and the derivative of g at 2 equal -2. Find k prime of 2. Well, the derivative here is the product rule. Derivative of the first times the second plus the first times derivative of the second. Here it doesn't matter how you do them, in which order, because you're adding those. And k prime at 2 is going to be f prime at 2. F prime at 2 is a 5. Times g. G is the original. That's a -4. Plus f. And f happened to be a 3 in this case. Times g prime, and g prime happened to be a -2, and that would be -20 minus 6, which is a -26. In part B, if I find the derivative of k, that's really derivative of the top times the denominator minus the top times derivative of the denominator all over the denominator squared. And if I switch those accordingly, so f prime is right there, g is right there, f and g prime, oh, I left this g out. So if I just replace those accordingly, and I forgot about g prime is right there. So if I replace those accordingly and simplify, so that's a -2, and f was a 3, g was a -4, so that's +4, minus a -4, so that's +4 times 5, and g was the prime, minus a -2 plus 2, and the denominator is f, which is a 3, minus g, which is a -4 plus 4. So that turns out to be, that's a 7, -14. That's a 7 plus times 4, that's 28, over 7 squared, which is 49. That turns out to be 14/49. Divide by 7. There it is. So this is nothing more than making sure that you know the rules properly and you could apply them properly. If f and g, here we just want an expression. If f and g are both differentiable functions, find an expression for the derivative of each. If I take a derivative of this, well, product rule. Derivative of the first is 1 over twice the square root of x times g plus the first times derivative of the second. So that's all we have to do. Just practice and make sure that we're getting this down. If I look at the second piece, well, y prime equal the quotient rule. But the top, when I say derivative of the top, that's the product rule. Derivative of the first times the second plus the first times derivative of the second. That's derivative of the denominator. Times, give myself some space, times the denominator minus the top times derivative of the denominator is 1 plus g prime all over the denominator squared. And there it is. Fairly simple if you know the rule. And if I take a derivative of the last piece, y prime equals the product rule. Derivative of the first, that's 3 times f prime plus 2x times the second plus the first times derivative of the second, which is g prime minus 1, and that would be it. Example 7. For what values of x does this graph has a horizontal tangent? Remember, if you have a horizontal line, the slope must be 0. If you have a horizontal tangent, that means the slope of the tangent is 0. Well, the slope of the tangent is a derivative, that is 3x squared plus 10x plus 1. And I want to know, where does that equal 0? That's 1x squared plus 10x over 3. I'm going to complete the square. Instead of using quadratic formula, take half of that, which is 5/3, square it, 25 over 9. That would be x plus 5/3 squared equaling, and if I get a common denominator, negative 3 plus 25 is 22 over 9. If I square root both sides, and x would be negative 5/3 plus or minus the square root of 22 over 3. You could use quadratic formula, of course, if you wish. That gives you the same results. And if I look at the next problem, find an equation of the tangent line. Well, to find the equation of a tangent line, y minus y1 equal m into x minus x1. I need a point. Doesn't give me a point. That is perpendicular to this line. Find the equation of a tangent line that's perpendicular to this line. So first, I need the slope of this line. The slope of this line is, I'm sorry, I rushed. You solve for y. If you remember, that's how it works. Divide by 3. Y equals negative 4x plus 5/3. So the slope here is negative 4. Find an equation of a line to the curve that is perpendicular to this line. Well, I know the slope already. I know it's going to be y minus, I need the point. I know the slope is going to be, since it's perpendicular, 1/4. Right? So, since this tangent line to this curve is going to be perpendicular to this, the slopes have to be negative reciprocals. So here I take the derivative of the tangent is going to be positive 1/4. Find the equation of a tangent line that's perpendicular to this. Yeah, so it's 1/4, my mistake. So how do I find the slope of the tangent? I take a derivative. The derivative of this is 2x. So that means x must be 1/8. Well, there's 1/8. And if x equal 1/8, how do I find y? Y would be 1/8 squared plus 5. That would be 1 over 64 plus 5. And what is that? that would be over 64. 64 times 5, 20, 320 plus 1, 321. I made this up, that's why the numbers are really messy. And that would be my answer. And that's how it works. And that's pretty much all I have to do. That concludes this section.